Welcome everyone to lesson 1.2, which is on percentage error. In this lesson, you're going to be calculating percentage errors of measurements and orally justifying your reasoning using some academic language such as measurement error, approximate value, and exact value. So first thing you're going to want to do is make sure your table of contents is fully updated. So to do that, make sure you have already numbered your pages that you used for lesson 1.1. And then update those pages right over here next to that portion in significant figures there, since we're done with that. Then go ahead and write today's date over here in the next line down and the title for lesson 1.2 as shown in this picture. So we are in 1.2 percentage error. So just as a reminder, we're in our second of 4 lessons. We've already talked about sig figs, and we're in percentage error now. All right, so let's dive right into it. So whenever we measure something, right, like we can try to get as accurate as we possibly can, but it's never going to be the exact measurement. And that difference between what our approximation is, just based on whatever tool we're using, and that exact value is called the measurement error, because it's the error in our measurement. So our precise definition here for measurement error is the difference between the exact value, which we'll use the notation V sub E, and the approximate value V sub A. So just the difference between those. One thing that's important to note is that measurement errors are always going to be a positive value. Even if you measure like 2 centimeters short of something, we'll still say that the measurement error is 2 centimeters. So for formula then, because this is math, we're all about formulas. They're great. They make our life easy. We can represent our measurement error as the absolute value. That's what those vertical bars are. V sub A minus V sub E. And again, that V sub A is the approximate value minus the exact value. So a quick example here. Say we have, let's make that go away. So we have a weight that measures as 102 kilograms. So like that's what we measured it as. But the exact value we know is 100 kilograms. So calculate the measurement error. So I'm going to be lazy and just use ME for measurement error. And right, we need to now identify which one is our approximate and which one is our exact. Well, we know, right, the exact value is 100 kilograms. So this is going to be our V sub E, which leaves this, the thing that we measured it as V sub A here. So now we can just substitute those values into our formula and spit out our measurement error. So we've got the absolute value of V sub A, which is 102, minus V sub E, which is 100. And we take the absolute value of that. So remember, absolute value acts like parentheses. It's a grouping symbol, so we have to do those things inside the absolute value first. And 102 minus 100 is 2. And the absolute value is just 2. Remember, absolute value just means whatever positive output it is. So if it was negative 2 in there, the absolute value would still be positive 2. And that is our measurement error. Simple as that. Cool. Let's move on to the percentage error now. So a percentage error is pretty similar to the measurement error, but this time you're just making it a percentage by dividing by the exact value to get that decimal value and then multiplying by 100%. So our precise definition again is the difference between the exact value and the approximate value as a percentage of the exact value. So that translated into a formula is right here. So you'll notice the top part is just the measurement error. It's exactly the same as before, V sub A minus V sub E. But this time we're dividing it now by V sub E to get that decimal, and then just multiplying it by 100%. So to show you how this works in action, we'll go back to that same example we just had where we have a weight measuring at 102 kilograms, but we know the exact value is 100. Calculate the percentage error now. Well, our percentage error, again, I get pretty lazy with writing. You can too. We're going to go ahead and identify these again, right? This is what we measured. So this is our V sub A for approximate, and our exact value V sub E is 100. So we just drop those into our formula. So the absolute value of 102 minus 100, all divided by 100, should always be dividing by that second number. And then we multiply that by 100%. So if we take this calculation out, we already know that 102 minus 100 is 2. So we've got 2 over 100 times 100%. And the absolute value of 2 100ths, well, that's an easy one to convert to a decimal. That's just 0.02 times 100%. Which, when we multiply that by 100%, we just move the decimal spot 2 places to the right, remember? So that gives us 2%. So our percentage error is 2%. That's how far we were off. All right, let's jump now down to a question that's a little more IB-like. The previous ones were just kind of as a demonstration. Here's kind of more something that you might see on an actual quiz or an exam. So the fraction 22/7 is often used as an approximation of pi. Kind of like we approximate pi with 3.14, 22/7 is also an approximation of it. So for part A, how close or to how many decimal places does 22/7 approximate pi? So this kind of question is actually just asking you to kind of write out the decimals and just compare them. So we're going to write out the decimal for 22/7 as close as we can, and then also for pi. And then we're just going to make some comparisons. So I'm not that big of a nerd. I don't have those memorized. So I need a calculator for that. So if we take 22/7 here, 22 divided by 7, right? We get 3.14, and it goes out for a while. Who knows how long? So let's write that out. This is going to take a little bit because it hates when I have this calculator open. 4, 2, there we go. And then we'll do the same thing with pi. So if we just enter pi in here and hit enter, we get 3.141592,654. All right, let's get rid of that for now. Then we can just compare, when these start to go astray. So we can see that, threes, okay, that's good. They both have a 3. They both have that 1. They both have that 4. But now is when things start to go different, right? Our approximations are a little off here. So that means that these, or to answer a question, how close does it approximate pi? To how many decimal places? It approximates it to 2 decimal places, right? 1, 2, because the third is where it goes off. So to 2, 2, 2, there we go, decimal places, or DP. And that's all for part A. Let's go now to part B, where we're actually calculating that percentage error of using 22/7. So, right, for me, it's always easier to identify the exact value first, and pi is clearly going to be the exact value. So that's going to be V sub E for us. Whereas our 22/7, right, that's our approximation. So that's going to be V sub A. So just putting that into our percentage error formula, which I've got up in the top right corner again, we'll get our percentage error. And we'll write this all out. So V sub A is 22/7. Go ahead, actually use these fractions here. Don't use those decimal approximations for them because, again, those decimals are approximations. So we don't want to get like errors with the approximations. That gets messy. So that divided, or minus pi divided by pi. And then we want the absolute value of that times 100%. And then we'll throw that into our calculator all at once again. Maybe if it'll pop back up. So we've got 22/7. We'll just take that. Now, if you just hit minus, right, it's going to take that answer. Minus pi. So minus pi. And we get that. Now we want to divide that difference by pi, which gives us that teeny tiny little number. And then multiply that by 100%. So just multiply it by 100. And we get that value. So our percentage error is equal to 0.0402499,435. All right. And now, let's see. Let me get rid of this calculator. Actually, let me just get rid of it entirely because it's bogging down my RAM. Now, remember 1.1, we always round our final answer to 3 sig figs. Yeah, we got to do that here. That's super important. So our percentage error is actually, for our final answer, well, now we need to round to 3 sig figs. So let's do the old start underlining the first the first 3 that we find. Well, that's going to be 402. So 4 is going to be our rounding number. 4 below, keep it low. So we're not touching that 2. We're going to leave it just as is. So our final answer here is 0.0. Whoa, I'm just going to scratch that out. 0.0402% because it is a percentage error, remember, which means I forgot my percentage there. Dang it, Roberts. Get your act together. All right, and that's our percentage error for part B. So that kind of wraps up this lesson, super short one. Just some key takeaways here, right? Since measurements are approximate, there's always going to be some kind of error in our results. So to calculate that error, we just take our approximate value or our measured value and subtract the exact value from it. If we're looking for the percentage error, then we're just taking that measurement error, that V sub A minus V sub E, and dividing it by V sub E, by that exact value, and then multiplying it by 100%. Of course, just like in that last example, never use any rounded like decimal approximations of a fraction or anything like that. Always use the exact value until the very end. That's when you should round your final answers. And that concludes lesson 1.2.